Welcome back to the XJet channel, and I've already had nearly 100 responses to my last video in which I've invited you to tell me what kind of plane you would like me to design and build for this little Cox Baby V engine. One of the things that I was thinking of though, a lot while we wait for the rest of you to have your say, is I wonder how many people actually understand how a model plane, or a full-size plane, like this for example, how do these actually fly? What are the physics? What is the theory behind flight? Now I know most people have a fairly basic understanding of the theory of flight, but I'm going to use this video just to give you a little more insight and to answer a few questions that some people ask and often isn't explained. So here we go. If you're interested, here is Flight Theory 101. Okay, let's take a look at the theory of flight. And look at this, look at that. I found a use for my Hobby King t-shirt, the one that shrunk beyond all recognition. Now I can finally put it to some good use as a whiteboard cleaner on what isn't actually a whiteboard, but is actually my cupboard in which I keep things. But it's the closest thing I have to a whiteboard, so we will use that for explaining the theory of flight. Here is an aeroplane, and a jolly handsome looking aeroplane it is too. I've drawn it specially for this little mini lecture. And the aeroplane itself, as you can see, has wing, tail, or horizontal stabilizer, has propeller up the front and a fuselage and a vertical stabilizer. And these are the basic fundamental parts of basically all aircraft in some way or another. Now, when an aircraft like this is flying, it's subjected to a number of forces. And the first force, the most obvious one, is gravity. Love these squeaky pens. Gravity. Gravity is what tries to pull the aircraft towards the ground. In fact, if I drop this pen, gravity takes over and it plunges earthwards, smashing into the concrete floor with great vigor and gusto. So, why didn't this pen fly? Because there was no force to oppose the gravity. We need an opposing force, and in fact, the force we use with our aircraft is one called lift. Lift is what provides the force to oppose gravity and keep the aircraft in the air. That's very simple, isn't it? Really basic. Now, there are two other forces that affect an aircraft when it's flying. One of them is thrust. Thrust, here we go. Thrust is what pulls the aircraft through the air. This can be a propeller, as on this wonderfully drawn aircraft. It can be a jet engine, it can be a rocket engine, it can be anything that basically pulls the aircraft through the air. It can also actually be gravity. Believe it or not, gravity can provide the thrust that pulls the aircraft through the air. But again, for every force, there's usually an opposite force. In this case, there is a force trying to pull back the other way, and it is called drag. Drag is the mean demon that opposes thrust and slows our aircraft down. So these are the four forces that we have to understand to see and figure out how an aircraft flies. Let's look a bit more closely at lift. Here is an airfoil section. This is the shape of a wing, a normal wing that produces lift on an aircraft. Notice that it has a curved top surface and a relatively flat bottom surface, and that's very important in the creation of lift. Now let's imagine we're moving this wing through the air in this direction. It will encounter air like so. Air will come along, or it will go along. The air will be deflected up over the top of the wing like this. And likewise, air on the bottom will travel along like that. Right. Now, if we draw a line at right angles to the wing, at front and back, we discover one very interesting thing. This path is longer than that path, which means in order for the air that comes over the top of the wing to reach the back at the same time as the air travelling along the bottom, this air has to travel much faster. It gets accelerated by the curve in the wing. And a gentleman by the name of Mr. Bernoulli, who was Italian, he found out that the faster air flows, the less force it exerts perpendicular to that flow. So basically, this air is travelling very quickly. It's not pushing out as fast or as heavily as the air underneath. So there's low pressure in this area because of the fast movement of the air. Underneath, the air is moving not so quickly, so the pressure here is not as low as the pressure there. The result is we end up with something called lift, which is an upwards force on the wing. That's how we get lift. At least that's the textbook version of how an airfoil wing creates lift. But I think if you've been flying models for any length of time, you'll know that it's not always like that. Not all our models have symmetric, have lifting wing sections. In fact, a lot of aerobatic models, for instance, have symmetrical wings, which have the same curved top and bottom. So how can you get lift from a symmetrical wing? Surely the path over the top and the path over the bottom is the same. In fact, some models even just have a flat plate. Take a foamy, for example. It just has a flat plate, there's no curve at all. But it still produces lift. How does it do that? Well, now we have to call on the experiences of an Englishman called Sir Isaac Newton. Sir Isaac Newton had a wonderful little set of rules or set of laws that he discovered in relation to physics. And one of those rules or laws is that for every action there is an opposite and equal reaction. Now let's look at the action. The air, notice here, if we draw a line through the middle of this whole setup, like so, that the air coming in is parallel to that line. But the air, after it's travelled over or under the wing, exits at an angle to the line. It is actually exiting with a downwards component. It's going down. So what Mr. Newton said was, well, if something's going down, something else has got to be going up. So the force that pushes that air down is reflected in the wing as an equal and opposite force that also wants to make the wing go up. So it produces lift. So there are two elements that produce lift in most aircraft. There's the Bernoulli effect, which is because normally they have a lifting section and the air has to travel further over the top than underneath. And there's also Newton's action and reaction laws, which say because the wing deflects air downwards, the resulting force lifts the wing upwards. And that's why when you put the nose of your model up, it climbs. As you increase this angle, the air is deflected down more strongly, therefore there's more reverse, opposite and equal force pushing up on the wing. That's how lift works. Let's take a look at another force. This time we'll take a look at thrust. Thrust is what pulls the aircraft through the air, and thrust is often provided by a propeller. Let's draw a propeller. We're going to draw this one from the end, as we did with the, let's imagine there's a propeller shaft through here. We've got a motor here. Here's our propeller. There's another blade over the back here somewhere, which looks like that. But you can see, edge on, that's what our propeller looks like. And because our propeller turns, it's cutting through the air. And that means that the air will be traveling like this, and it will actually be directed backwards by the propeller because of the angle and the shape of the airfoil section. Now we all know that when we have an action, air being pushed backwards, there's an equal and opposite reaction, so the force applied to the motor will be to pull the aircraft forward. That's very simple, isn't it? That's how thrust is created by a propeller, but there's also other forms of thrust, of course. We could have a little jet engine here, which sucks air in the front, blows it out the back. Again, Mr. Newton comes into play. Because there's a force pushing hot gases out the back, the equal and opposite force provides thrust to pull the aircraft forward. That could also be a rocket engine, anything else. This is how thrust pulls the model forward. Now, what about a glider? Where's the thrust to pull a glider forward? It doesn't look like a glider, does it? Sorry, but that's the best I can do. I'm not an artist, but imagine for a moment this is a glider. What makes that glider travel forward? Where is the thrust required to pull it through the air? Well, I'll tell you what. Imagine this glider is sitting on a little ramp that we've built for the purpose, like so. Imagine it has a little wheel at the back and a little wheel at the front. That glider will roll down the ramp, as you would expect. And that is where our thrust comes from. What happens with a glider is that we substitute height for distance. So we're turning all the energy, the potential energy in our altitude, into kinetic energy by moving the aircraft forward. So our thrust actually comes from gravity. If you look at it from gravity's point of view, you're pulling it down, you can just get a little bit of an angle on it, and that's what pulls a glider forward. That's where the thrust comes from in a glider. Of course, the downside is that as you're moving forward, you're constantly losing height, unless you had a thermal or are flying in slope lift. So on a still calm day, a glider will always come down and land. It won't stay up forever because the source of the thrust is the energy represented by your altitude, your height above the ground. Let's look at the fourth and final force that acts on our model, or any aircraft for that matter. Let's assume this is a fuselage or anything that is travelling through the air. And here comes the air again as I draw with my red lines. And you can see that the air has to go around the object. Now, whenever you move something, a certain amount of force is involved, a certain amount of work is done. This air is being split apart by the movement of this object. So there is work being done to split the air apart. That energy to do the splitting has to come from somewhere. And where it comes from is the forward motion of this object or the flow of the air. And the force actually manifests itself as something we call drag, which is going to go in that direction. It's going to try and make either in the case of an aircraft, it's going to try and slow it down. And if that was just sitting in static, if that was static and this was the airflow, try and make it move with the air. So there are several factors that affect drag. The bigger the object, the more the drag, because the more air has to be parted. And also the shape of the object has an effect as well, because the more rapidly you have to part the air, the more energy gets turned into drag. So in that case, if we were to make a blunt front on this object, like so, it would have more drag, because now the air has to make a more violent detour to go around it. So more energy is required to accelerate that air more quickly. So if you understand the basics of drag, you can make your model more slippery. You can create less or build a model with less drag, and it will fly faster than a model with more drag. So what I'm going to do, if anyone wants it, is in future mini lectures, I will tell you all about the different types of drag, because there is more than one type of drag. And I will tell you how to design models to minimize the drag and therefore get maximum speed from the same amount of power. And if you're interested, drop a message on the bottom of this video and I'll do my best to knock up something, just a few minutes explaining the different types of drag, how to reduce them, and how to make your models fly a lot faster. Okay, that's it. That's my introduction to flight theory. There's a lot more I could tell you, but I won't bore you to tears at this stage. If you want to hear more, then put a comment on the bottom of this video, and if there's enough interest, I'll do some more flight theory videos explaining some of the finer details, things like center of pressure, center of gravity, all those things that affect the way models fly and are a factor when you're designing a model from scratch. And designing a model from scratch is a wonderful thing to do. It's really, really fun, because there's no other way of turning an idea into a flying model. And when you do that, when you take an idea and you turn it into a reality that actually flies, that's a real buzz. That's one of the best things you can do, in my opinion, in this hobby. Yeah, you can build ARFs, you can fly RTFs, but you don't get the same buzz as being able to say, that's my plane, I designed that, and I built that, and it flies. That's a real buzz. So if you want to see more, post a comment on the bottom of this. In the meantime, I've had a lot of feedback already on my Build Your Own Park Flyer from Corflute video, and so far biplanes seem to be in the lead in terms of the designs you'd like to see me build. So if you don't want a biplane, better get on the other video, post a comment telling me what you do want. In the meantime, by tomorrow this time I should have had enough votes or enough recommendations to make a decision, and I will start the design and build of whatever it is that you people decided you want me to build. Then will come the videos showing that whole process. I'll explain everything as best I can, we'll build it, and we'll fly it. So thank you for watching in the meantime, and stay tuned. Subscribe if you're not a subscriber, because you could miss the next exciting installment. Thanks for watching.